Okay, so this is a beautiful Tesla Talisman 308u. It's from the beginning of the Art Deco era with the bullet style shape. We have pretty simple radio with 4 tubes. Has a volume knob with on-off switch. We have the tuning dial, tuning knob, and band select here switch. But first of all, let's talk a little bit more about the appearance. We see we have we have the pointer here that goes both sides from the Tesla logo here, which is a very beautiful little dial. We will clean it. The cabinet is bakelite, and as you can see, it's in fairly good shape. I don't see any scratches, any chips or marks, or so this should clean really well. We have these fins here that still have some dust inside, and we will clean them very good. But some plastic polish will do wonders. I liked this radio. I would have liked it black. I don't think if a black model was ever available. It's available in different colors. I found and was looking after this brownish color. It's a dark brown color, but we will see how it looks after we polish it. Pretty good. The knobs are in fairly good condition. No big scratches, no nothing. The grill cloth, which is actually, I don't think it's quite a grill cloth, it's a cover for the speaker, but it shows as a grill cloth here. It's in fairly good condition. Now, what do you expect with this radio? This is a very compact radio in a bakelite case that has some vents here. It's also breathing through the back. We will look at it in a moment. But most issues in a radio like this, the majority of them, are caused by heat building up inside. So our number one enemy with this type of radio is heat. There is not a lot of space, not a lot of area for the heat to dissipate and to get out of the radio, so heat will build up extremely fast in this radio. It's a tube radio, so we will start looking for things caused by heat most of all. Now, if we take a look here, you can see the sides are in pretty good condition. We have let me see if I can move the light a little bit so we can see it better. I think it looks fairly good. Yeah. Of course, you need to clean the face of the radio. These are the knobs, so we have no big scratch on the bottom. It looks almost perfect. We have no problem here. And on the side as well, there is nothing. I really like the grains of this bakelite. I believe that when it will be polished, everything will be magic or beautiful. So you can see the difference here on top. Even heat can usually causes this, but also wiping and cleaning this area a lot have taken the lacquer off of the top of the radio. Now, when we look at the back side here, let's do this. Okay, so this is the back side of the radio. So what we have here, we have the brand, we have the model number, is made in Czechoslovakia. It's AC DC set, so it works with AC and DC as well. As you can see here, the symbol. We also have the voltage selector here. It's a 110 and 220. It's now set to 220 volts. We have for the AC operation a 30 to 100 cycles per second or hertz frequency of operation, so that's no problem. We have the tube layout here. It's a UCH21, UCH21, UBL21, and UY1N. This is the rectifier tube. This is the output tube. This is the I believe it's an IF amplifier, and this one is the oscillator and mixer. I believe. We will take a look at the schematic, but judging from the fact that this tube is much closer to the input, it makes sense that it is a mixer oscillator. This should be an IF. We see the IF on both sides. We see the output tube here, a UBL21, and the rectifier somewhere in the back. Also, we can see that here we have the mains input, so it makes sense that the rectifier should be in this area somewhere. Yeah, we have the input for the antenna, so we can use a long wire as is pictured here. This is the input for the antenna, and this is the input for the ground. We can ground this to some earth ground or to some water pipes or whatever, cold water pipes. This was used in the old days to ground these radios, and it worked very nice. We can see we have one screw here and some missing screws here. And what else can we say? We see some damage here. This, I believe, is a hit related issue. Why? We can see we have the rectifier and the output tube here. I also can see, you will see it better when I take this cover off. You will see that we have a dropping resistor here for the mains that also generates heat. So there's a lot, or the majority of the heat is building up in this area, so it's softened and damaged this cardboard or whatever this material is, and it started to break apart. So let me get a screwdriver here. Let me find a screwdriver. I don't know, this is too small, but it works. Let's take this screw off. And I believe this is one of the original screws that came with the radio, because it has a pretty nice shape to it. It has some slope on the head. It was a little bit abused some time ago, I can see here, but that's good. We have it here. Let's see. Oh, line cord. Looking at some pictures online and trying to find information about this radio, I believe that this is the original line cord that came with the radio from the factory. Yeah, this one. Let's see. You see, it's in fairly good condition. The plug, it's an old style plug without the slots for earthing. So this is a 2-wire cord, of course, textile. That's normal. It's in fairly good condition. I don't think we can use this in all European plugs anymore, because the sockets have some formations in them here, so we need some slots here. So we will see what we can do about it, but it's in fairly good condition. That's surprising. Usually when we talk about line cords, they are not in pretty good condition or working order. So we can see here we have damage in the back panel due to this this thing here. So the radio has been worked on, or at least opened a few times. You can also see the serial number punched in this back panel here. So see on the back, not much. So this is the inside of the radio. Let me see if I can get you a little bit closer. Good. So this is the inside of the radio. As we were saying, this is the dropping resistor. We see it's a nichrome wire, most probably wrapped around some ceramic former, and we have one section here and one section here. Here is completely missing, and it was replaced with another resistor, also with nichrome wire. What are the odds of this? This is the dropper resistor. This I expect to get pretty hot. This is the output tube, and this is the rectifier back here, and these two tubes and this resistor, I think, and should be the hottest things in this chassis. And as you can see, there is not a lot of room in this chassis, not a lot of room at all. So things are getting toasty in here. I also see some marks. Let's see if I can get you even closer, a little bit closer. Let me show you. So if we look, these are the IF transformers, okay? So if we look, the IF, these are the trimmers or the coils. I don't know exactly which ones are, but they have some tuning slugs inside them, and they are plugged with some wax. And as you can see on this transformer, which is further away from the heat, the hottest things in the chassis, so let's call this the cooler part of the chassis, these slugs still have some wax in them. But if we look on these ones, the wax seems melted, and I think I can even see hard, but I even see some the head of the slugs in there. So definitely this IF transformer has been much hotter than this IF transformer. Now what happens in these little radios is that the hotter it gets inside, we have a problem with things that have liquid in them. So for example, electrolyte. So if we talk about capacitors will be the first ones to fail in these radios. And we are talking about electrolytic capacitors, maybe the filter capacitor, which is back here, or all the paper capacitors in here, everything that has some liquid inside. The liquid will get hot and will start to evaporate, and this will cause their ESR, equivalent series resistor, will get even will get higher. As the resistance increases, then the capacitor will get even warmer, because dropping a voltage on a resistance is power dissipating as heat. So there will be more heat generated inside the capacitor, they will heat up even more, and tubes get hotter, and this is a self-sustaining cycle that ends up in a disaster. Either the tubes go away, or some resistors go away, or the capacitors go away, they short something, maybe they blow a fuse. We'll see if there is a fuse inside of this radio, but it's a catastrophic failure. Now we will be keeping an eye open for all of these things. Now to open this radio and get the chassis out, we have to take this screw out. There is one more screw back here, if you can see it. Yep, we can. And I think that's about it. Let's see. Let's take a look at the chassis. Good. So we need to do one more step. We need to take the knobs off. This is one of the things that troubles me the most. Let me show you. See, this one is a better example. Let's see if they all are the same. Okay, good. So good. And this knob is not in the right place. This is the band selector knob. It should be on the other side. Okay, so as we can see, we have metal shafts for all of these controls, and maybe, I'm not sure, but we can check this out, maybe, but usually there is things like that, these controls are connected to the chassis. So remember, we have no isolation, no transformer, so that means no isolation, and one of the lines from the plug, from the socket, from the wall, can be attached to these shafts. Now these controls have metal screws, and as you can see, they have really deep, let me show you here, they have really deep slots in them. And usually, and I believe I'm right if I can find something here, usually they use these small head screws that go all the way inside here. Come on, all the way inside here. So as you can see, it has a relatively small head. It goes all the way inside here, and they use to plug this hole and cover the head of the screw with some wax or tar or something, so that you do not make any contact with the metals, because if this is live, depending on how you plug this thing in the wall, that's pretty dangerous, as you can imagine. And now let's try it. Let's see, from the back side, have a little tab here that we have to lift up. And let's try to take it out. Oh yes, here we go. Easy. First, let's take a look on the inside here. So there is a grill cloth. Huh, I did not expect that. So we have a grill cloth. What is this? Some spider web. Good. So we have some felt. Yeah, it's felt, it's not foam. Some felt here that keeps the speaker from banging on that front plate. The chassis is also held with this tab here. And dust, a lot of dust, but nothing that cannot be cleaned. I'm so glad that we have no chips and no missing parts of this case. This case is beautiful. It will clean beautiful, so I'm pretty glad. Now let's have a closer look. Are we resting on the speaker? Of course we're resting on the speaker, but I'm not worried about it yet. Let's see. What can we see here? Yes, we can see a splice here. We can see another splice here, another splice here, another splice here. So it appears to me that this is factory. Are all the same type of resistors, spliced with caps inside them. Look at this cap, this big bad boy with a lot of wax in it. So this all looks factory original. Wow, interesting. Talking about 3D and spatial construction. So we have some more caps in here. See if anybody worked on this thing. Nope, I don't see any signs at first look. Big boy here. We have an oh, this one is replaced, and I believe this is a 4700 picofarad. So this has been replaced. You can see it was clipped here and soldered to the existing wire, the existing lead of the former cap. And this, my friend, if I'm not mistaken, this is what we call a dead cap. So pretty strong word for a cap, but this is tied from the line input to the chassis somehow. So put some sort of cloth in here to isolate the outside of the cap. Interesting. And also you can see the line cord, some pretty horrible soldering done. Let me see if I can get you closer, a little bit closer, so we can see better what I'm talking about. Look at that soldering. That was my 4-year-old kid with something that gets hot, not even a soldering iron, trying to solder something. That's horrible. This is a Russian cap. The dead cap, it's a Russian cap. All the other caps are the original Tesla, made in Czechoslovakia, paper cap, 600 volts. We have a 250 volts, 750 volts, 307, I don't know what that is. We're resting on some dial lights and I don't like that. So this one, I don't know what this is. We have to take a closer look at it. Oh, it seems like also a paper cap. A 0.1 microfarad paper cap. Yeah, that's a paper cap. Why do I have 2 voltages on it? I don't know. So, what else? Also this type of mica caps in here. The volume with the switch. Oops, something went click. Okay, so we are gonna lose these things. Let's see, what do we have in here? Try not to lose any parts and bits. This is a 6.3 volt, 6.3 volt, 0.3 amps, 300 milliamps. So this might also be original. The guy took this radio from says it's working, it's operation, it's working, but this is working. That's impressive. 6.3 volt, and we cannot read anymore. Probably 0.3 amps, 300 milliamps, and it looks okay. We will check this. Good. Okay. Let me see. How is this held in here? Oh, like this. Okay. So to get this out, we need to bend a little bit this tab, just a little bit, just to make room to play a little bit. Okay, and now we should be able to take this out. A dial. Come on. Okay. So you can see we have some tape, textile tape, wrapped around the edges to keep it safe from the metal. But we have a little bit of a chip here. It's not a big deal. It's not visible from the outside when it's inside the case. And this looks perfect. Perfect. Good. Perfect. We'll put this in a safe place. Okay, now I was looking at this thing and trying to get this pointer out of here, and I tried pulling on it gently, but it's not coming out, so I found it. I found a way to take it out. So if we take a look in here, I don't know how well you can see this. Let me try. Yep. So okay, so here is the string, the dial string. This is the dial string here, and when I tune it and I move it, you can see a little bit of a hole coming up here. You can poke a small screwdriver in here, and there is a set screw that holds this little needle pointer, and when you loosen that up, you can take out this little pointer. Don't try to force it out. Okay, so I managed to take the speaker out. All I had to do is desolder these two leads on top, yeah, from the primary of the transformer, and these two screws on the bottom to the bottom of the chassis, and it all gets out. Now a neat trick I use is I always put the screws back into the holes where they belong to. I try to keep the minimum screws, the minimum quantity of screws that's possible outside of their holes, so that I don't lose them and misplace them or insert them in the wrong hole. Now let's try to see what's underneath this little bag here. The speaker, it's a paper cone. Never seen one so unpainted, let's say. So the spider, it's okay. No rubbing in the cone, in the voice coil, and it seems quite nice. Suspended, so the speaker is perfect. Thank goodness for that. Okay, so what I've started to do is rewind with some nichrome wire, this big resistor. I cleaned the terminals, and now very carefully, well, this is hard to do not under the camera, but under the camera it's even more difficult. This is a 0.1 millimeter diameter nichrome wire. It has I believe it's lost it. Go back a little bit. Wow, this is not a good idea to do this under the camera, but so this I cannot do it under the camera. So this nichrome wire is 0.1 millimeter or 36 AWG wire. It has a resistance of 17.4 ohms for 10 centimeters or 52 ohms for 30 centimeters wire. I have here a bobbin of 2 meter and I guesstimate that I need around about 1.2 meters of wire wounded on this big bad boy. And what I did, as you can see, there are some little spades here, some little terminals here, and also this bobbin as well, which is from factory. It's wounded around this little terminal, and I put a blob of solder on this side, and I believe it's pretty stiff. I pulled on it and it's okay. So if we don't get so hot that the solder to melt and the bobbin to unwound, this is how I do it. And you really have to leave just a little bit of a space between each wound, each turn. The idea is that if afterwards under the magnifying glass we can take a look into the Sharpie or something, we can arrange just a little bit the wire. So what we do is just go very, very slow, gentle, with tension, always with tension. Don't drop it. If you drop it, you're gonna start all over again. So this is how it works, and I hope I can fit 1.2 meter of wire right in here. And we can go with a Sharpie, that's what I was saying. We can go with a Sharpie and arrange a little bit of the turns to tighten them up, or yeah, whatever. And from time to time we will check the resistance that we have between the terminal and the amount of wire that we have wound. So yep, this will take some time, and when I have something to show, I will come back. So thank you. Okay, so what we need and what we ended up with. So we need, if you can see, we need here a 700 ohm resistor and a 200 ohm resistor. And what we end up with, it's something like this, where I have connected one, this is the 700 ohm resistor, and this is my wound resistor. And if you can see, I started up from there on this side. I started up from here and I started wounding, and it doesn't have to be just perfect, but good enough. And don't worry if you short some turns. The resistance is so low that a few shorted turns will be no problem. Kind of gotten with the spacing, trying to fiddle around with it, but don't be too picky. And when I ended up here, I started turning, wrapping around. Then I went through the hole once, and that's what I soldered here, and then a few more times on the other side. And I did not solder it completely all around because first of all, I left me some wire here as a reserve if I need more, or if something happens. But I wound it up more. I got around 250 ohms of resistance. I stopped from time to time and measured the resistance, and I did it intentionally to go a little bit over, because we are on 230 something volts, AC volts, and yeah, I want to drop a little bit more than 220 originally. So we will see what voltages we get with 250 ohms of resistance. This might vary a little bit when we solder it, and if we move the turns around, but it's pretty good. Have 250 on one side, and we have 697 ohms on the other side. So we're good to go. We've resurrected wirewound resistor. Let's proceed. Okay, so what I have done so far, I have removed the tuning condenser, and it is being cleaned right now. I'm using the ultrasonic cleaner. I haven't changed this electrolytic cap and also this paper cap here, but I've cleaned a little bit the chassis, only dusted. Now I will get cleaning with some chemicals or something. Let's see what we can do. On the bottom side, you can see here is the ground lug from for the antenna, and it's tied with a 4.7. It was a 5 nanofarad cap, paper cap, from here to ground to chassis, but I've replaced it with a 4.7 nanofarad cap to ground. I use the safety cap. I don't want this ever to become shorted and tie the chassis to the ground terminal. This can be dangerous. It would have been nice to have 1000 picofarad or 1 nanofarad safety cap as well to tie to also tie the antenna to the coil, to the input coils, but that's more or less okay. It's isolated through more than one cap from the chassis and some resistors and whatsoever. I also used this 4.7 nanofarad cap in here. This is from the plate to the cathode of the rectifier tube, and I also don't want this to short out anytime soon. I've checked all the resistors. They are pretty much spot on, no problem. I kept the same idea with flying leads and point-to-point wiring. I really liked it. I also replaced here a 500 picofarad cap. That was a paper cap. I swapped it with a mica cap, 500 picofarad 1% mica cap. What else can I tell you? Oh yeah, I had here I needed here 68 nanofarad cap. I did not have the yellow. Sorry, 1 second. So I didn't had the I did not have a 68 nanofarad yellow cap from the same line as all the others, so I used a 68 nanofarad orange drop instead. That will work just fine. Oh yeah, I checked all of the caps outside foil and I marked them, and I installed them the correct way. I will change the rest, and we will go forward from there. As you can see, there are some grommets that I want to replace. These are the original grommets. As you can see, they had this metal insert inside them, and they go here into these holes. Yep, to mount the tuning condenser. They are not brittle, but they are starting to get there, and if I'm removing the tuning condenser to clean it, I thought why not change them all together. So these are the new grommets, pretty good quality ones, fresh with the metal insert, and I think they will fit just fine. Let's check it out. Yep, pretty nice. Everything will work just fine like this, and then the tuning condenser will be mounted on this rubber grommet so that we don't have a connection to ground, to chassis ground anywhere, but only on one tab to keep the RF ground isolated from the rest. And also for some shock absorbent. To remove the dial, it was pretty easy, no problem whatsoever. Everything, the dial string is very easy and has, oh, okay, remembered. I also changed some wiring, as you can see, the white wire back there and a few wires here in this area. The wire that was in there, it's pretty bad, as you can see. It's toast. This is the big one, so you can see it's so brittle and dry from the heat and from all of these years, and we risk getting short somewhere, so I don't want to risk that. I want this radio to be good for the long run. I also, as you can see, the caps that I took out, this big fella here, this was a 0.64 microfarad, a 640 nano, and I replaced it with a 680 nano, a 0.68. It's this big guy right here, so that's no problem whatsoever. You don't really have to be that precise. This is the cap that I replaced with the orange drop. This was a 0.064, a 64 nanofarad cap, and I replaced it with the orange drop. This guy here is a 0.1 cap, and it's a precision, a plus minus 10% cap. It's this big guy here on the bottom. These caps are spot on. This measured 101 nanofarad, while this one, actually let's measure it. Let's see how far this one drifted. I don't remember. Let's do some measurements. Measurements are always fun. Let's see what we get here. 132, so we are 33% above. So usually when paper caps start to get leaky, when they start to pass DC, they start reading higher in value. So yep, let's try this big fellow here. I don't remember if I measured it or not. So we should get 640 nanofarad, and we are 853. So you can imagine the state of all of these paper caps by now. As you can see, they start melting from one end or the other. So not terrific anymore. If we try and take a look at the schematic here, you can see some resistors that I spot checked. I also checked this 100 ohm here. It reads like 97, 98 ohms, so I left it alone. It's no problem. This is the 0.064 that I replaced with the orange drop cap. This is the 0.64 that I replaced with a 68 nanofarad, 680 nanofarad cap. So yeah, as you can see, this comes straight from the line. Across the line we have two bulbs in series, so they are kind of acting more or less like a fuse, let's say, and it ties directly to ground. This I would have preferred to have a safety cap, but I don't have the appropriate value, and nah. Yeah, that's it. This is the safety cap that I replaced. This one here, as you can see, it goes straight to ground, to chassis ground, and it's connected to the terminal, the ground terminal for the antenna, and it was supposed to be a 5 nanofarad, and I changed it with the 4.7 nanofarad capacitor. So I still have to replace this cap here. It's across the primary of the output transformer, and it is on the output transformer, and I have to replace it still. What else? Oh yeah, the electrolytics. I'll see what I'll do about them. And yeah, All right, so progress update. I have sprayed some contact cleaner in the potentiometer, the volume potentiometer, and I'm cleaning it. And after a couple of sprays with that contact cleaner, which evaporates entirely, leaves nothing behind, I have sprayed some WD-40 inside, and I'm playing with it a little bit. I will do so tomorrow one more time. After one day, I have lubricated and installed a dial cord, and I also did some contact cleaning on the switch, the band switch. What else? Okay, I have installed the electrolytic. I have placed two 47 microfarad Nichicon electrolytics inside this can. It's not that pretty on the bottom. Oh, the reason I have some some paper here is that I don't want the contact cleaner inside the volume potentiometer to go all over the place. So as you can see, I've opened the base and I crimped it back up. Nothing special. I installed the tuning capacitor with the new grommets all cleaned, and I also installed the wheel with the dial cord. As I said, it's working fine. I have replaced this cap here on these coils, and I cleaned a little bit the chassis, not too much. It's not gonna be a shelf queen, this is gonna be a working radio. Okay, so we are now connected to the Variac. I brought it up slowly with the dim bulb limiter. We are now feeding in 231 volts AC. We are up to full line voltage. And let's see if we power up. We have a little bit of volume. I'm not expecting much because in my area there are no AM stations, only one, and it's very weak. So this is some power supply or something, and this is me. Where is it? This is me feeding 6 millivolts RMS 1 megahertz carrier signal with a 1000 hertz modulation. And modulation I'm feeding in the antenna port, so we see we can find something. I don't know what's the claimed sensibility for this. Is a problem that I believe is related to the tubes, these random noises that are coming and going. So we should have long wave 60 microvolts. 60 microvolts. Nah, not that sensitive, but we can see here this is the voltage that's on the output of the rectifier, and we should be around about 190 volts. I measured all the voltages in the radio and we are 10-15 volts below. Okay, so I have swapped all the tubes. I have inside brand new tubes from the rectifier to the output tube and to the UCH21 tubes. So we are all brand new spanking tubes. Let's see what happens when we start, what happens with the voltages, and if we get other different sensitivity on the antenna input. Put the mains on, straight to 127 volts AC input. So let's see how long it takes for the B plus voltage to come up. Much faster, and we shoot up to 253, and now the tubes should start to conduct, and high voltage start to drop a little bit. See where will we settle. I'm still measuring the output of the rectifier tube. We are on 180 89, so we are much closer to the schematic voltages. Let's see what happens here. So we have a little bit of volume. Interesting. I still have my antenna connected, full volume. I'm on 1 megahertz with 6 millivolts RMS. Might be that one of my new tubes are bad. That would be nice and interesting. Let's see what happens when you touch the antenna. So we get something in the speaker, that means the output tube is working. It's dead silent, that's interesting. Let's see if we bring some oscilloscope probe near this thing. Do we have any oscillator? No oscillator whatsoever, absolutely nothing, nowhere. So we have no oscillator, means we have bad tubes. Let me swap the UCHs back for the old ones and see what happens. That's one tube. Let's see now what happens. If we get anything different. Let's increase the amplitude to 9, 10 millivolts RMS. Let's see what happens. Interesting. That means bad contacts on the pins, so we have to clean the pins. Let's make a good contact, but this one much better. Let's see now. Wow. 4 millivolts RMS. Bad contacts on the pins. Let's swap the former tube and see what happens. Okay, now let's see what happens. This is the new tube back in. Let's give it a chance to warm up. Yep. And we're back. Anything else? Picking up something bad over there. It's another power supply or something. That's my signal generator. I think I'm gonna keep the resistor, the wirewound resistor, as it is. So I'll be back. Okay, so now we have the electrical restoration complete. I've added fuses and the line cord so that we can plug this thing in. How can I show you this? Which way is better? This way. So what I did, I put a couple of fuse holders here. I bolted them to the chassis. They are plastic insulated, so no problem whatsoever. I've wired the fuses with these two little wires to the switch. I have both the live and the neutral fused. I used 630 milliamp for each line. I've measured the amount of current that the radio is drawing during normal operation. It's somewhere around 200 milliamps, so with a 600 milliamp we are fine for the inrush current and everything. As you see, I have this reproduction line cord, a textile one. It looks pretty awesome, and I have run it to this grommet here. I've used rubber grommet on the chassis. I also used two zip ties locked together and super glued to the cable. Then I used this silicone coated, and it has some I don't know, fibers inside. It's a very high heat resistant insulator, just because it runs very close to the pins of the rectifier tube, which gets hot, and I don't want anything to happen to the cable here. At the end, I had the textile cut and super glued just a little bit so that it won't unfold, and just as a matter of another precaution, I used some heat shrink over the super glued portion, so that we have no problem whatsoever. This is quite stiff. I also bolted it to the chassis. This is not going anywhere. It's not pulling any stress on this on the cable whatsoever. This is tight. This is a little bit further away from the grommet, so that I don't want it to rub against the grommet, and this way it's sitting pretty much solid, rock solid. Yeah, so this is for the input side. I have used this type of plug. I really like this type of plug. I will remove this label here, but I really love it. It's for it's for two wire cable, and it's very nice because when you plug it out of the wall, you're not pulling on the string to stress on the cord to stress the wires. You're pulling it from like this, and it's very, very handy, and I really like them. They are cheap. I ordered them online, and they are also black, which I like. And that's about it. This is where we are. So we are going further with the alignment very soon. I don't think electrically we have anything else to do. I will go over the alignment, and at that point I think the electrical restoration is complete. I kept the new to be seen. I've cleaned the pins, and we are in pretty good shape right now. Thank you, and when I'll have anything else, I will come back.
Okay, so we are set up for the first alignment. The first alignment always is the IF alignment. I have the radio in a pretty awkward position because we need to access the top coils from the IF transformers. What I have set up: the radio is on. It's on the variac with the isolation transformer. We have a roughly 227 volts AC in. You can see I'm monitoring the output of the rectifier. We are on 190 volts, somewhere around here, and we are okay. The way the radio needs to be set up: we need to have it on 200 meter, the dial pointing at 200 meter on the scale. We need to be on medium wave, and we need to feed in the grid, the control grid of the first ECH21, the first heptode, the input heptode, the mixer. We need to feed in via a 30 nanofarad capacitor. I'm not using the 30 nanofarad capacitor. I have my little boxes that provides me isolation and protection for my spectrum, for my signal generator. You need a modulation. It's not specified in the instructions, not specified, so you need modulation. Of course, you need something to get through. I have my scope monitoring the output at the speaker. So loose connection there. So if we take a look here, can we focus on this? Okay, so we are on the first line. We need to inject the signal, modulated signal. I have a 1000 hertz tone in it with a 30 nanofarad on the first grid, the control grid on the first heptode. We need the 452 kilohertz. That's the IF frequency of this radio. Modulated, I'm AM modulated 80% with 1 kilohertz tone. We need the dial to be pointing at roughly at 200 meter or somewhere around there, and we need to align L24 plus L24 tilde, whatever that symbol is, then L23, 22 and 21, and we need maximum output we can get. So where are these coils? Well, we have this little diagram here, and you can see the IF transformers, and we have roughly L24, the two coils with one slug, L23, 22, 21. Yeah, so let's do this. Okay, let's come back. So I am right now feeding an 80 millivolts RMS signal into the radio. I've cleared the slugs of the IF coil. They had some wax on them, so you need to clean that first before you can align it. Let's focus on the oscilloscope. We have something on the oscilloscope, so let's start with L24. Let me, if I can find it. Yep, I have the volume on maximum, and I can hear it getting louder. Let's decrease our signal level. Why aren't you triggering? Where is my trigger? Where are you, little trigger? Come on. No trigger? No trigger. Yeah, we need roughly. Let's get it even smaller. Yep, we're on 40 millivolts right now. Let's start. I think I hit the bottom. If we go, we need to screw it in. Okay. Let's start with the second transformer. Come on. Okay. This is in the wrong direction. I need to go the other way around. Let's go small. 15 millivolts RMS. Oh. And we have an increase. 5 millivolts RMS. 1 millivolt. Let's see with 1 millivolt. What will we get? Let's go. 2 millivolts. And we are bottomed out. Let's try the other ones. This is somewhere. It was okay. This one. Oop. We got it again. 1 millivolt RMS. Now we're getting somewhere. Okay, let's go one more time. This one is bottomed out. This one is bottomed out. So pretty much this is it. Let's go. Yeah. You can use an analog meter as well instead of the oscilloscope, or you can even use the speaker just for the maximum loudness. So pretty much we're in the neighborhood now. We are okay right here. Okay, so that's it. Let's try something else now. Okay, now we're ready for the next alignment. This is the IF trap on the input of the antenna, to show you. So through the socket of the antenna, if I hold it like this, so we have to go into the socket of the antenna. I'm using an RMA dummy antenna. We need 452 kilohertz modulated on medium frequency, and the pointer on medium wave, and the pointer at 500 meter. We will have to adjust L40, the coil L40, for a minimum deflection. So we are on medium. We are pointing right at 500. This is 500 here. This is the broadcast band, the medium wave. We have. Oops. Let's go like this. We have roughly 60 millivolts RMS input. And let's take a look at the oscilloscope. At first, coil L40 is this one right here. Is right. It's tuned from the outside, from the front of the radio. So if we take a look, this right here is the L40. Let's go ahead and tweak it. Let's see what happens when we tweak it. And we are getting smaller. I lost it. Now we've passed it. Let's go back. We've hit a minimum here, so this right about here we have our minimum. So yeah, that's it. So we have to do the RF alignment and antenna picking. So same setup as before, still using the RMA dummy antenna to feed into the antenna inputs. I have the radio on the side just because we need to adjust the oscillator coils and capacitors, and the antenna coils and capacitors are here on this side of the radio. If we take a little look here, so we are at this step. We still have to feed through the antenna input. We need 6 megahertz on short wave. The dial is pointing to 50 meters, and we adjust the L28 and L27. L28 is the oscillator coil, and L27 is the antenna coil. Yeah, so if we take a look here, we can see that L28 is this one right here, is the central one nearest to the band selector, and L27 is this one right here on this side. So let's do that. I have 6 megahertz configured on the 6 megahertz on the signal generator, still modulating 60 millivolts RMS. So we put some volume here, and now let's look at the. I have set the pointer straight to 50 meters. Let's go. So this is the coil.
Here I passed it. Here I passed it again. So this is it. We are now with the oscillator right on frequency, and we need to adjust L27, L27 being this coil right here. Let's see if we can pick it out, can get some gain or not. So here we are getting away. It's increasing, now decreasing again. So right around here we are right at maximum. Now we have to switch to 15 megahertz and move the dial to 20 meters. So let me do that. Okay, so now we are on 15 megahertz and we are pointing at 20 meters. We need to adjust C14 and C13. These are capacitors, and if we take a look here on this paper for just 1 second, we can see that first of all we need C14, which is the oscillator, and C14 is this one, is right next to the L28 coil, and we need C13, which is this one for the antenna to adjust and pick the upper bands. So the biggest problem is that we have these caps are like tubular with some wires, and I don't know what are our odds to adjust these caps here. Let's see if we search. So here it is. It's our signal. We are pretty close. I think we are super okay with the upper frequency. We are almost bang on the mark. We are not even 1 millimeter away, so I'm not gonna mess with it. These capacitors are pretty horrible to adjust. Let's go for medium wave. So we need 550 kilohertz for the medium wave. We need to move the pointer to 545 meters. Let me show you. Here we go. So we need 550 kilohertz for the medium frequency, 554 meter pointer, and we need L35 and L31, L35 being the oscillator. And if we take a look to find them, L35 is right over here, this one is, and also L31 should be this one. So yeah, we are okay now. Let's go ahead and do that. I'll be right back. Okay, so we are now set. I'm on 550 kilohertz on 545 meters, more or less. It's pretty close. I wouldn't even bother with it, but let's do it just for fun because it's a coil and we can work that out. So L35 is the one to the exterior, this one here, this one here. Let's see what happens. Good, that's about it. And we also need L31, which L31 is the one right here. Let's see if we can pick this up. And we are now perfect. Let me move to, we are now perfect. Let me move to the bottom end. We need okay, so for the bottom end we need 1500 kilohertz at 200 meters, and we need to mess around with C31 and C27, the same tubular thingies. So if we're pretty close, I'm not gonna bother. We are right on the money. I'm not gonna mess with it. So last one. Last one is the long wave, and we have to go for 160 kilohertz, 1875 meters, and we need L34 and L33. Yeah, let's go do that. And just a sanity check, if we talk about L34, is this one right here from the inside of the radio, and L33 is, which one is it? This one, bottom one. So let's go. Okay, I have set up. We are on 160 kilohertz, and we are pointing straight at 1875 meters. Let's start with L34, which we said it's the one on the inside of the radio. That means this one right here. We are pretty close anyhow. We are going away. The other way around. Let's give us a little bit of volume. And that's pretty much it. And for the antenna, let's pick it. L33 is the bottom one. So let's see what can we do about the antenna. Not very sensitive. Almost getting the slug out. Now we're going down. So somewhere around here we are on maximum. Good. So we've completed the adjustments, all of the adjustments. Now all it's left to do is add just a little bit of wax. I took a regular candle that my grandmother has from church, and I will drip just one drop on each coil that we moved so that they will stay put. Okay, so let's do a little sanity check. I now have next to me the Pardot antenna. I have it here, the mini whip. I have the power supply right here. It's off right now. Let me put this somewhere out of our reach, somewhere that's a little bit higher. We are indoors, everything is connected. Let's search the long wave for something. Let's see with the mini whip antenna off. Let's put some volume here. We're on maximum volume. So we have absolutely nothing. Let's turn the antenna.
Na dystansie 1500 metrów wygrała Karolina Bosiek. Zapewniła sobie start w lepszej grupie podczas kolejnego Pucharu Świata. Zresztą całą niedzielę 19-letnia Tomaszowianka może zaliczyć do udanych.
That's with the antenna off. Let me show you with the antenna.
Jestem do poprawy, ja cały czas będę do tego dążyć i mam nadzieję, że to wszystko przyjdzie.
To drugie wspomniane miejsce na podium dywizji B to drugie miejsce Artura.
So this is another bit of radio, Romania radio, with the antenna off, nothing. This is with the antenna on. Good. Let's check out another band. We have the mini whip on. I don't know what this is. We are on medium wave.
Sunat pe o vreme foarte însoțită la vot și să aflu și care este,
And
să spunem, starea de serviciu a românilor
antenna
care s-au
off.
prezentat la vot. Am întâlnit un număr
Antenna
mult mai
on.
mare.
Good. Let's see on shortwave. I don't know what was that. It's interesting. A lot of silence. And with the antenna off, nothing. With the antenna on.
عيني صبيانيك بلو كر لبيانيك
شورو شدا
It's very crowded in this region here. This is some digital stuff. But as I told you, with the grounding system, the antenna works perfect. No problem whatsoever. Very crowded. This is where band spread would be coming handy. So yeah, this is it. See you soon.